Hello everyone, I'm Prasad from Structural Guide. Today we are going to discuss about structural elements of the building. This is a basic presentation on the structural elements of a structure. We are not going to discuss in detail. This is a kind of introductory presentation on structural elements. We discuss what are the basic elements in a structure that is used to support the loads exerted on that structure. Right, let's start. Now you can see there is a list of structure elements on your left hand side in the screen, but let me violate that order and present it in a manner that will be more easier for you to understand. First, let's start with this figure. As you can see here, I have written the slab. The slab is the most important element when it comes to the covering the area. So it is the element that cover the area of the building. Also, it is the horizontal element most of the time that we apply most of the loads. Okay, so we put the tables, we sitting there, we put many things on the slab, right? Therefore slab is very important to us. Now let's see how it is important. Now this is certain load applied on a slab. So the purpose of the slab is to transfer this load to the beams. That is the function of the slab. So depending on the ratio, that is aspect, depending on the ratio, this span, we say Lx Ly. So shortest span we say Lx, and long span, so let's say Ly. So depending on this ratio, the load on the slab, and based on the location of the load on the slab, the load will be transferring mechanism of the load will be on the transfer mechanism of the load to the beam will be varied. That's the basic idea. The slab is the most of the time cover the area. So now let's move on to the beams. You can see this is the beam, the element that cover or that runs around the slab panel is called a beam. So this is a beam. So the function of the beam is to get the loads from the slab and transfer this load into the columns, right? So whatever the loads come to the beam, it will transfer to the columns. That is, slab is held by the beams most of the time. So beam will transfer load to the columns, right? We have discussed about two elements now, beam and slabs. Right, now let's move on to the columns. The vertical element of the building is the column, right? This is the column element. So the function of the column is to transfer the load coming from the beams to the foundation, right? So vertical element is transfer the load to the foundation. Depending on the nature of the structure, there may be inclined columns or even horizontal columns, but the function of the column is to transfer loads from the beams to the structure. But there are different occasions, special occasions, where it may not be connected to the slabs. Other than that, usually in a building, it's connect with the beams and it transfer load to the foundation, right? Column is an axially loaded element. The axial load will be carried by the column, right? Next we discuss about the foundations. Right, now you can see this is the foundations. The element that connect with the column is the foundation. So the load coming from the columns will be transferred to the soil or ground by the foundations. That's the function of the foundations, right? When it comes to the foundations, there are many types of the foundations, right? Mainly there are two types of foundations, that is shallow foundation and deep foundation. These two types of the foundation are there. So let's start with the shallow foundations. So when it constructed at a shallow level, they are called the shallow foundations, right? When you have a shallow depth, then they are shallow foundations. So when the structures load is very small, you have a individual foundations for each column. Say this circle is a column, right? So you have individual footings like this. So when you have a smaller load, then we have good bearing capacity to transfer that load to the ground. Then that case you use the individual flat footing or shallow foundation type single spread footing, right? So there are occasions where we have to combine two columns together like this. There may be different occasions, but these kind of foundations are called the combined footing. We connect two columns together and do have a single foundations. Other than that, there are another type of foundation that is called strip foundation. That is, so you connect several columns together like a strip. So this is called the strip footing. So this selection of these type of foundations come with the bearing capacity, applied load, are the main, come with those factors, because those are very important factors when it comes to the size in the foundations. So if we have low bearing capacity and considerable load, it may not be able to put a single pad footing. Then you might need to combine. Even if you have even further, you might need to combine several footings together to get the higher area for the foundation. With that, you can have a foundation for smaller bearing capacity. When you have a smaller bearing capacity, you have to increase the area of the foundation. When if you have a small load, because your bearing capacity is small, right? Let me explain that in little bit more. Now your foundation bearing capacity is come with this. Say this, if it is your allowable bearing capacity, the force divided by the area will give the allowable bearing capacity. Right, now when you know the allowable bearing capacity from the soil investigation report, so you know the allowable bearing capacity. Now you know the column load. If you know the column load, you can calculate the area. Area is A into B, footing length and width. So your footing will be like this A and B. So your area can be your area will be A into B equal F divided by allowable bearing capacity. So column load, you know, when you have a strip footing also, you have a total column load, then from that you can calculate this area. So this is a concept. I'm not going to discuss in detail. I'm telling you the concept, how it comes or how it's vary. Now as I explained previously, we have a smaller bearing capacity, your area of the footing will be increased, because when you have a smaller bearing capacity, when this figure is smaller, getting smaller, this will be increased. Therefore you have to have a higher bearing capacity, higher area. Okay, that's all about the shallow foundations. Now when we can't build the structure on the shallow foundations, for example, when you have very high load on the columns, so you might not be able to do it with the soil or shallow foundations, because soil has a certain limitations, cannot bear all the loads. So when you have a very high load, we have to go into the rock. So your column will be like this. So you have a pile cap, and then you continue the pile into the rock, right? Those are the elements I told you in a deep foundations. So you have a pile here, then you have a pile cap, and you have a column, and in addition to that you have the ground beams, right? This is the finished floor level. So ground level may be somewhere here or somewhere little somewhere below here. So you have a pile cap, and you have ground beams and piles. So we have a several element in a structure like this. Mainly 3 elements like this. Pile is the one socketed into the rock, or socketed or anchored in the rock. So it will directly transfer load to the rock. Then when you rest the building or foundation on the rock, you have a higher bearing capacity, so you can easily transfer the superstructure load to the rock or the ground. This is the basic elements that we want to discuss. I'm not going to discuss the function of this element in detail, but these are the three elements we have to come up with we have to consider when you do the design, right? So I think I have discussed about the foundation. Now I have discussed about the pile, and I have discussed about the ground beams. So ground beams in a shallow foundation, it might be called as the ground beam or tie beam sometimes, right? This is also kind of a tie beam. So in a shallow foundations, we having tie beams will enable to a certain extent us to control the different settlements, in addition to the load transferring coming from the ground floor walls. Wall load will be directly transferred to the columns from the ground beams. So that is the, in addition to that, it will assist in a structure in controlling the different settlements, right? Those are the main elements of the foundations. So two elements to discuss: shear wall and the corbels, right? What is shear wall? When you have a very tall structure like this, you have this is a very tall structure, so we have a lateral load on this structure. What are the lateral loads? You may have a wind, you may have a earthquake load, or any other load, blast load. So those load will be applied on this structure. Mostly your wind will be always there, so earthquake load and blast load will be not always there. It's special loads that may be applied on a structure, but wind is always there. So when you have a wind load on a structure, tall structure, there will be very high bending moment on the foundation. So we have to control, otherwise this column beam frame structure have to bear this load. So it will be very difficult, because we might need to have very high elements. But what we can do is, we can introduce shear wall in a structure like that, right? So this is the plan. So say we have a wind load or lateral load from this side. So what we do is, we put shear walls in that particular direction. So most of the time these shear walls are kept at the lifts. Around the lift we provide the shear walls. Say this is a lift, so these perimeter walls around the lift core are constructed as reinforced concrete walls. So those act as the shear walls. So if you have a lateral load like this, these two walls will bear those. So for example, if you take this example, so in this lift, these two walls can carry the loads applied from this side. When you have a load from this side, this type of wall doesn't work, but this wall will work. So you have to have a walls in this direction. So we have to keep these walls symmetrically, then there won't be any torsional effect in a structure. So let me briefly explain about the function of the lift wall. Now shear wall. So if you have a wall like this, say two walls, something like this, when you have a lateral load like this, the more effective type is this, because this one easily it will bend. This is a plan view. This will easily bend, right? When you have wall like this, when you have a lateral load like this can easily bend that way. But when you have a wall like this, when you have a load like this, it will be difficult to bend in this direction. But other direction it will be easily bent. This way it can easily bend, but along the wall it will be difficult. That's why we put the walls in the direction of the loads. So this wall will be effective for these loads in this direction. When it comes to other direction, these other walls will be become effective. So that's the function of the shear wall. Then the last item is the corbel. When you construct the main structures or dams or bridges, you need to have a precast element kept in those structures. In a bridge, you first build the reinforced concrete structure, abutment or the piers, then you place the precast beams. To place the precast beams, you need a cobble. So cobble is an element like this, so it can it is used to rest the elements like this. In addition to this, even not only the precast, post tension, any element you can keep it there. Even in the column also you can have the same thing. We can see, say this is your column, so this is your corbel, so this is a corbel, this is a column. So these kind of elements, corbels are constructed even in the column. When you have a construction in second stage, in a column also you can see the element will be like this, right? So this is a side elevation, so it's like this, so corbel will be like this, right? So they have a surface like this, so you can keep the beam or anything on the top of that, right? So this element is called the corbel, right? Those are the things that we are going to discuss today. I think we make an introduction to the structural element of the building. So this is a very basic video. We were discussing preliminary concept, that is basic element or the main key element of a building. So there are some other elements like concrete retaining walls and all that are there, but today discussion is limited to the building. So I hope we were able to share certain knowledge on this. Thank you very much for watching our videos. Let's meet again for a video. Till then, bye.